Hello, my name is Dr. David Kordowitz, and welcome to programming. Today we're going to talk about some of the mathematical operations in MATLAB and how they differ from those in C and C++. Let's begin. As we know from previous videos and previous discussions, the mathematical operations in MATLAB are very similar to those in C and C++. The only difference is that MATLAB treats all variables as matrices as opposed to as single numbers. That said, most operations will work exactly the same unless you're dealing with matrices and other matrices. So let's take a look here. If I say, for example, a equals 2 plus 3, my result is going to be 5. Same with b equals 3 minus 2 is going to be 1. b equals 2 times 2 will be 4. And c equals 4 divided by 2 is going to be 2. So this works all the same. Now, the percent key in MATLAB is our comment. So percent is not modulo in MATLAB like it is in C. If you want the modulo of something, you simply go and use the mod command. So d equals mod 5, 2. And if I do that, I'm going to get 1 because the remainder, right, 5 divided by 2 is going to be 2 plus a remainder of 1, so our modulo is going to be 1. So this all works basically the same. Just remember that you need mod instead of the percent sign. But other than that, these are pretty much identical. Now, where things change is when we start doing things with matrices. So let's say I have A equals 1 colon 5 and B equals 10 colon 15. So these are the same size, these two matrices. When we think about it, if we want to multiply the values in those matrices, in C we would have to do it using a for loop and index through and do each of our multiplications separately. If I do A times B here in MATLAB, it's not going to work because I'm trying to multiply a 1 by 5 by a 1 by 5, and as you know, in matrix multiplication, the two inside numbers need to match to be able to multiply. So, for example, I can take the transpose, which tips the thing to its side, the array to its side, and I can say, for example, A times B transpose, and the transpose is represented by the apostrophe. Now, this is going to do a matrix operation. And again, it's going to throw an error because I guess that the B is actually 6. So I can do B equals, and if you hit the up arrow, you're going to get the previous time that something B equals something. So let's try 14. Now let's try our A times B. And that works, and we get a single value. This is because we've now have a 1 by 2 and a 2 by 1, which means the outer two digits are 1 and 1, which means we would get a 1 by 1 as our result, which is 190. Now, if you did this the other way and said A times B, we would get a 4 or 5 by 5, which would be these outer numbers because now we have a 1 and 1 in the center, and we have a 5 and a 5 on the outside, so you get a 5 by 5. Now, what if this isn't what we want to do? What if we want to go element by element, so we want to multiply each of the values? Instead of all of this matrix stuff, all we need to do is add a period in front of our times, and it will go element-wise. So what that means is we're going to get 1 times 10, 2 times 11, 3 times 12, 4 times 13, and 5 times 14. If we do that, we get 10, 22, 36, 52, 70, which is exactly what we expected. So if you see here, you have the ability to go element-wise if you want to, and you have the ability to go matrix-wise. So what about division? Division is exactly the same thing. So if I say A divided by B, it's going to give me a number, but the fact is that that number is doing matrix inversions, and 0.263 isn't exactly what we want. We actually want a dot divide by B. And then we get our 5 numbers. So 1 divided by 10 is 0.1, 2 divided by 11 is 0.1818, 3 divided by 12 is 0.25, and so on and so forth. So this dot allows us to go element-wise. What about powers? So let's say I want to go I want to say a squared. So I can do a raised 2. Well, that's going to be a problem because a caret 2 is telling it that we want to do a squared, so it's going to multiply a by a. And since it's a 1 by 5, you can't multiply it, or 1 by 5, you can't multiply it by another 1 by 5. So let's say I do a dot square. That'll go element-wise and go item by item. So that saves us a lot of effort. So let's start a new script file to take a look at what we can do. So as always, we're going to start our script file with close all, clear vars, and CLC. Again, I always like to start my scripts that way to guarantee that I get a clean version of everything that's going on before I start. We're going to look at the distance between two randomly generated point sets. So let's say x1 equals, and we're going to say rand of, I don't know, let's say 10 elements. And then we're going to say that y1 equals rand of 10 elements. We're then going to create an x0, which is going to be exactly the same as x1 as far as how we declare it. So I'm just going to go ahead and copy my x and y and just change these to 0. So now we can calculate the distance between these two sets, but just for interest, let's go ahead and scatter plot these. x1 comma y1. And then what I'm going to use is a hold command. So I'm going to use hold on. And what that does is that keeps the current plot on the window so that we can add a second plot. So I'm going to go scatter x0, y0. You always need to remember anytime you use hold to cancel it. So always make sure you put a hold off. If you don't, you may have problems if you try to run additional plots throughout your program. So let's go ahead and run this real quick. And my scatter plot comes up over here. And you can sort of see that one set of my scatters are blue and one set are red. This is pretty typical for newer versions of MATLAB. It used to be slightly different colors if you go back more than about 3 or 4 years, but the new color scheme is pretty nice. So we have one data set in blue and one data set in red. If you notice when I get near one of them, it fills in the circle. If you click, it will give you the value of that point. So this point has an x of 0.39 and a y of 0.7209. If you want to label them, you can use the legend command. So you can say legend, and I can say x1 and x2. And what that'll do is that'll put a little legend in the corner of our plot. It'll take a second. That tells us which data set is which. So if you notice, our points change a little bit, and that's just because this is random in nature. Okay, so let's compute the distance. So we know that these are two vectors, so we need to treat them element-wise. So we can say d equals the square root of the sum of squares. So square root of, and then we want to take the square root of x1 minus x0. Now these are each of these values is going to be a vector. So when we square it, we need to use the dot power operator. If we don't, we're going to have errors. Then we're going to do the same for the y. y1 minus y0 dot raised 2. Now we can close our parenthesis and it'll show us which ones are matched. However, in this case right now, we only have the square root of each of these individual distances. So if we run this, we're going to get back a vector. And that vector is going to be a vector of distances that contains the distance from each point to the final point. But that isn't really what we want. We want the square root of the sum of squares, so we want the sum of all of these. So you add sum on the outside, and sum only works in one direction. So if you need the sum of all of the elements in a two-dimensional array, you have to nest the sums. You can also pass it as a second term which direction you want to go. Direction 1 will always be in the y direction, direction 2 is in the x direction, and direction 3 is in the z direction. So we have this value now, and let's go ahead and add a display line, disp d, and let's run it. And we run it, and we find that our square root of the sum of squares is going to be 2.0983 units. So this is our total error. But if you see here, I'm using my dot power and my and other mathematical operations to work here with the vectors. You can do many things using these different variable types and variable methods. I'd like to thank you for your time today, and see you next time.